Hi Year 12, this is the second video for the solutions to the 2020 Extension 1 Maths HSC exam. In this video we're going to look at questions 11 and 12. Question 11a. Let p of x equal x cubed plus 3x squared minus 13x plus 6. Part 1, show that p of 2 is equal to 0. So we just need to substitute in 2 for x. Which is equal to 8 plus 3 fourths of 12, take away 26 plus 6, which is equal to 20, take 26 as minus 6 plus 6 is equal to 0. Part 2, hence factor the polynomial p of x as a of x times b of x is a quadratic polynomial. So in part 1 we found out that p of 2 is equal to 0, which means that x minus 2 is a factor. So let's use a long division. And divide x minus 2 into x cubed plus 3x squared minus 13x plus 6. X into x cubed goes x squared. Multiply x cubed minus 2x squared. Subtract 3, take away negative 2 is 5. Minus 13x. X into 5x squared goes 5x. Multiply 5x squared, take 10x. Subtract minus 13 plus 10 is minus 3. Bring the 6 down. X into negative 3x is negative 3. Negative 3 times x minus 2 is negative 3x plus 6 is 0. So here is b of x. So p of x is going to be equal to x minus 2 multiplied by x squared plus 5x minus 3. 11b, for what values of a are the vectors a, negative 1 and 2a minus 3, 2 perpendicular? So remember our dot product needs to be equal to 0. Nice easy question. So we have got a times 2a minus 3 minus 2, and this has to be equal to 0. So 2a squared minus 3a minus 2 is equal to 0. And we need to factorise it. You can use quadratic formula if you want to. It's pretty easy quadratic to factorise. Factors here are 2 and 1. I reckon I'm going to go 2 and 1. I want negative 4 plus 1. So therefore a is equal to negative 1/2 or 2. 11c. The diagram shows the graph of y equals f of x. Sketch the graph of y equals 1 over f of x. So remember, anytime we've got y is equal to 0, like here and here, 1 divided by 0 approaches infinity, so we have an asymptote. So we've got two asymptotes here. Now we need to figure out what is happening in between negative 2 and 2, and what is happening outside of that. So let's start inside here. We'll start with this point here. So 1 divided by negative 3 is negative 1/3, so that's probably about here. And you'll notice that this curve is always negative. You see that? So if I do 1 divided by negative, I'm going to get a negative. So this is going to spin around and go down like this. Now we need to figure out what's happening up here and then up here. And you'll see when we are close to 2, our y value is small, and 1 divided by a small number is a big number. And then as we go towards positive infinity, 1 divided by a large number is a small number. So we're going to get this sort of curve like this. And this is an even function, so it's going to do exactly the same on this side. And so we will have an asymptote here at y is equal to 0. Question D, by expressing root 3 sine x plus 3 cos x in the form a sine x plus alpha, solve this equation. X is in between 0 and 2 pi. Okay, so remember R, oh, they've got A. Okay, fine, A is equal to the square root of root 3 squared plus 3 squared, which is 9. So 12 is 2 root 3. And then we're going to have tan of alpha is equal to 3 over root 3. that is equal to root 3. So alpha is equal to pi on, let's see, 360s pi on 3. Okay, so we have got root 3 sine x plus 3 cos x is going to be equal to 2 root 3 sine x plus pi on 3. And that is going to be equal to root 3. So sine of x plus pi on 3 is equal to root 3 on 2 root 3, which is equal to half. Okay, so x plus pi on 3 is going to be equal to, so if the sine of a half is pi on 6, now let's think about where we are. Sine is positive here and here, so it can be pi on 6 or 5 pi on 6, but I'm going to keep my eye on it just in case we're going to need an extra one. We are going to need an extra one. So I'm going to take this over the other side. I'm going to get x is equal to pi on 6 take pi on 3 goes negative. And then 5 pi on 6 take pi on 3. Fractions. 5 pi on 6 take pi on 3. 2 pi on 3. It's 3 pi on 6 pi on 2. So this one's gone. Now, anytime this happens, consider that you may have to come around and up into this first quadrant again, which we have to. So here I'm going to put an extra one on, which is going to be 2 pi plus pi on 6. So that brings me into here. 2 pi plus pi on 6, so what is that? It's 12, 13 pi on 6. Let's just rub that out so we've got some room. 13 pi on 6. And so down here we're going to get 13 pi on 6 take away pi on 3. I'm going to do some more fractions. 13 pi on 6 take pi on 3, which is 2 pi on 6, gives me 11 pi on 6. And you can see that that is in between 0 and 2 pi. So these two are our answers. 11e, solve dy dx is equal to e to the 2y, finding x as a function of y. So we're going to split the variables. So we've got dy dx is equal to e to the 2y. Let's take this over the other side like this and bring the dx over to the right hand side. Now this is incorrect what I've written. We must have these integral signs. Now that left hand side is the same as e to the negative 2y dy is equal to integral 1 dx. Okay, up here we've got e to the negative 2y divided by negative 2 plus c is equal to x. And we want x as a function of y. In fact, that is it, isn't it? X is equal to negative a half e to the negative 2y plus c. 12a, use the principle of mathematical induction to show that for all integers n greater than or equal to 1, this is true. So let's start with n is equal to 1. So here is our left-hand side, here is our right-hand side. Left-hand side is equal to 1 times 3 minus 1 is equal to 2. Right-hand side is equal to 1 squared times 1 plus 1 is equal to 2. So therefore it is true for n is equal to 1. Now let's assume it's true for n equals k. In other words, that the sum of k terms is going to be equal to k squared k plus 1. And now we're required to prove it for n is k plus 1. So here's our statement we're aiming for, that the sum of k plus 1 terms is equal to k plus 1 all squared multiplied by k plus 2. Okay, so let's start. Sum of k plus 1 terms will be equal to the sum of k terms plus the k plus first term. So from our assumption, we get k squared, k plus 1, and our k plus 1 term, k plus first term, is going to come from here. So k plus 1, brackets, 3 brackets k plus 1 minus 1. All right, let's see where we're going. All right, I'm going to bring the k plus 1 out the front. Let's see what I get. K squared plus, I'm in here, 3k plus 3 minus 1 is equal to k plus 1. K squared plus 3k plus 2 which is equal to k plus 1. And factorising here, we get k, 2, 1 plus plus, which is equal to k plus 1 squared, k plus 2 as required. Therefore, true for n equals k plus 1, and by the principle of mathematical induction, true for all n. 12b. When a particular bias coin is tossed, the probability of obtaining a head is 3/5. The coin is tossed 100 times. X is the random variable representing the number of heads obtained. This random variable will have a binomial distribution. So it is distributed as binomial with 100 trials and a probability of success 3/5. Find the expected value, that is equal to NP, which is 100 times 3/5, which is 60. Part 2, by finding the variance, var x, show the standard deviation of x is approximately 5. So using our formula, we have NP, 1 minus P. Now NP was 60, and 1 minus P is 2/5. So that's equal to 24. Our standard deviation is the square root of variance. And using my calculator, the square root of 24 is 4.899, which is approximately equal to 5. Part 3, by using normal approximation, find the probability that x is between 55 and 65. So we know that the mean is equal to 60, and we know the standard deviation is equal to 5. Because we haven't been given tables, we're assuming this is going to be an empirical rule question. So this is 60. We're going to add a standard deviation and subtract a standard deviation. And probability that x lies between 55 and 65, remember, 68% lies within one standard deviation of the mean. Question 12c. To complete a course, a student must choose and pass exactly 3 topics. There are 8 topics from which to choose. Last year, 400 students completed the course. Explain using the pigeonhole principle why at least 8 students passed exactly the same 3 topics. All right, great question. We have to combine pigeonhole principle with combinatorics. There are 8C3 ways to choose a combination of topics, so that's 56. So that's the pigeonholes. There are 400 pigeons. So 400 divided by 56, that is equal to 7.14. So if all the topics were, or the combinations of topics, were divided exactly evenly, then you would have 7 in each pigeonhole and 0.14 left over. So by pigeonhole principle, at least, that's meant to be a T, at least 8 students, so we're rounding this up to 8, passed exactly the same topics. 12d, find the integral between 0 and pi on 2 of cos 5x sine 3x. These, of course, are the products to sums and differences. So we've just got to look on our reference sheet and find cos sine, which is this one here. So we're going to rewrite this as between 0 and pi on 2 of a half sine a plus b, so 5x plus 3x, minus sine ax, 5x minus 3x, brackets dx, which is, bring the half out, 0 pi on 2, sine 8x minus sine 2x dx. Now integrating, we're going to get negative cos 8x on 8 plus cos 2x on 2 between 0 and pi on 2, which is equal to a half. Negative, it's going to be messy. Cos 8 pi on 2 is 4 pi on 8 plus cos 2 pi on 2 is cos pi on 2. Take away, don't forget your brackets, put 0 in, negative cos 0, remember cos 0 is 1, plus cos 0 on 2 equals a half. What's cos pi? This is cos 2 pi. I'm just going to do a quick sketch. That's equal to 1. So negative 1/8 plus cos pi, here it's negative 1, minus, come up to here, negative 1/8, and then here is a half, equals a half. Probably should do it straight on my calculator, I can't be bothered. Negative 1/8 plus an eighth, it's gone. Negative a half, take away a half is negative 1. Answer is negative a half. 12e, find the curve which satisfies the differential equation dy dx equals negative x over y and passes through the point 1, 0. All right, again we're going to separate the variables, so y dy is going to equal negative x dx. Don't forget your integral signs. Integrating y squared on 2 is equal to negative x squared on 2 plus c. At x equals 1, y is equal to 0. 0 is equal to negative a half plus c, so c is equal to a half. So we've got y squared on 2 is equal to negative x squared on 2 plus a half, times everything by 2. Y squared is equal to negative x squared plus 1, and take the x squared over. We have a circle centered at 0 with radius 1. And that's it. So our last video for this will cover questions 13 and 14.